Hello everyone, welcome back to my channel. In this video lecture, we will cover a new chapter of chemistry, that is thermodynamics. So basically, what is thermodynamics? It is a science which deals with study of different forms of energy and quantitative relationships. There are two types, system and surroundings. The part of universe for study is called system and the remaining portion is surroundings. State of system and state function. State of system is described in terms of temperature T, pressure P, volume V, and etc. The property which depends only on state of function, state of system, not upon path, is called state function. Example: pressure, volume, temperature, energy, heat, etc. Extensive and intensive properties. Properties which depends on quantity of matter is extensive property. Example: mass. And the properties which do not depend on quantity of matter present are called as intensive property. Example: temperature. Internal energy is the sum of all kinds of energy with a system, and it is a state function and extensive property. Heat is a form of energy which is exchanged between system and surrounding due to difference of temperature. Unit is joule or calorie, where 1 calorie is equal to 4.18 kilojoule. Then the first law of thermodynamics states that energy can neither be created nor be destroyed. It may be converted from one form to the another. Mathematically, delta U, which is the heat, which is the internal energy, is equal to Q plus W, where W, work done, is equal to minus of pressure into delta V. Delta V, that is the work of expansion. And when we put the value of W in the first law of thermodynamics equation, it gives us delta U equals to Q minus P delta V, that is equal to delta U plus P into delta V, and where Q and W are not the state function, but delta U is the state function that stands for internal energy. Enthalpy is equal to U, internal energy, plus pressure into volume. At constant volume, V is equal to 0, and if V is equal to 0, QV is equal to delta U and QP is equal to delta H. Delta H, then it will be equal to delta U plus delta PV, which will be equal to delta U plus P delta V at constant pressure. According to this, the relationship between QP and QV is equal to QP equals to QV plus P delta V. And relationship between QP, QV, that is delta H and delta U, is also equal to QP plus QV. QP equals to QV plus PV, which is also equal to QV plus delta NGRT. Then exothermic and endothermic reactions. Delta H is equal to negative for endothermic and delta H equals to be positive for endothermic reaction, that is evolution and absorption of heat. Okay, then enthalpy of reactions. The enthalpy change taking place during reaction. Standard enthalpy of reaction. Enthalpy change of reaction taking place at 1 bar pressure and 298 Kelvin, with reactants in their standard states. Different types of enthalpy. Enthalpy of combustion, enthalpy of neutralization, enthalpy of formation, solution, ionization, fusion, sublimation, vaporization, atomization, and hydration. Now the most important topic, Hess law. Hess law of constant heat summation is the total states that the total amount of heat change is same whether the reaction takes place in one step or in several steps. Then what is bond enthalpy? It is the amount of energy released when gaseous atom combines to form 1 mole of bond between them, or heat absorbed when 1 mole of bond between them are broken to give free gaseous atom. Further, delta bond enthalpy, yani bond enthalpy, is equal to bond enthalpy of reactant minus bond enthalpy of products. Then what is spontaneous and non-spontaneous process? A process which can take place by itself is called spontaneous, and which can neither take place by itself or by initiation is called non-spontaneous. Driving force for spontaneous process is first tendency for minimum energy state, second tendency for maximum randomness. Entropy It is also important. Entropy is measure of randomness or disorder of system. That is, gas is greater than liquid, liquid is greater than solid. Entropy is denoted by S, whereas in which S is equal to Q reversible upon T. Spontaneity in terms of delta S of total is equal to delta S universe, which is also equal to delta S of system plus delta S of surrounding. If delta S of total is positive, the process will be spontaneous, and if it is negative, the process is non-spontaneous. Then second law of thermodynamics states that in any spontaneous process, the entropy of the universe always increases. A spontaneous process cannot be reversed. Then Gibbs free energy, it is denoted by G and is defined as G equals to H minus T Sg, which is also equal to H minus Ts. And delta G is equal to delta H minus T delta S. It is Helmholtz equation. Delta G is useful and delta G is equal to W useful equals to work done in the maximum. If delta G is negative, the process is spontaneous, and the effects of temperature on spontaneity of a process is for endothermic process it may be non-spontaneous at low temperature, and for exothermic process may be non-spontaneous at high temperature and spontaneous at low temperature. So these are the written formulas. You can take the screenshot of it and help it. Thank you for watching my video. Hope you liked it and understood it. Please don't forget to subscribe my channel and don't forget to like, share and comment. Thank you.